Our second example on a graph is showing this oval shape. Again, I would suggest that you use our index card strategy. So we're going to slide the index card until the first place that it touches the relation. And in this case, if we count on the x-axis, we're looking at -1, -2, -3 is that first location. So our domain is going to start at -3. Then we'll grab that index card and slide it. And it appears that the last place that it hits the x-axis is at +3. Then we'll go ahead and move the index card out of the way. And in this case, it appears that everything is solid on the circle relation that we see here. So we're going to use those square brackets, no open dots or infinities to worry about for the domain. Checking out the range, we start on the bottom. We scroll up. The first place that it hits the relation is right there at -5. And then if we move it up to the highest point on the y-axis, in this case, we're up here at +5, one above the 4 that's marked there. Again, if we move the index card out of the way, you'll notice there's no infinities to worry about here because we didn't have to add arrows. There's also no open dots to worry about, so square brackets for both. Taking a look at our third example, you can see on this one that we've got an open and a closed dot to be concerned about. So we'll see how that works as far as our notation is concerned. Again, starting with domain, if we slide over, the first place we see the graph, if we kind of highlight here along the x-axis, looks like it's at -5. And then we'll slide that index card to the other end down here, and it ends at that closed dot, which looks like it meets the x-axis at 4. And getting the index card out of the way, now we can analyze a little bit here for our notation. So at the -5, at the point over here, we're looking at an open dot. So we want a parenthesis for that one. Versus over at the other side on the right at the 4, that's a closed dot, so we can square bracket that in. So it's okay for things to mix match. That's perfectly fine. We use whatever the graph shows us to determine what's what. For our range then, sliding up to the first place we see the relation, it's right here at -2. And then if we move that index card up to the very tippy top, looks like the first or the last place that it's going to hit the graph is up at y=3. Again, we'll get the index card out of the way so we can see the graph and analyze for notation. At -2, it's an open dot, so a parenthesis, and at +3, it is a closed dot, so a square bracket. And then we've got 3 examples on the last page. You can either follow along with the video or maybe pause it and then check your answers and come back. So let me move our index card over. There we go. On our last page, we come back to an example where we have to analyze before we get started, because in this case, it appears that our graph gets chopped here at the end. So we're going to go ahead and add those arrows. On the previous 2 examples, it was a circle that was completely included, and the other one had open and closed dots to end the segment totally. But this one, it looks like it should have gone further. The graph just had to end at the given slots that we had here. So for our domain, we'll slide over now our index card, and the first place that it touches is here at the y-axis, so that's actually the x value 0. And then if we slide the index card the whole way to the end, again, we run into that arrow that we just added, so an infinity. So I know automatically that that is a parenthesis. However, the 0 is at a solid dot because it doesn't appear that they put anything open there, so I can put a square bracket around it. Talking about the range, I'm going to slide the index card up, and it looks like the x-axis is the first place that graph touches, so that's again going to be a 0. And as I slide the index card up to the tippy top, the last thing I hit is that arrow, which is heading upwards as it heads to the right, so it's going to be a positive infinity again. So in this case, this example, the domain and range are completely identical. Doesn't happen all that often, but it can. Example 2, if we get our index card out of the way, analyzing the graph, you might want to add lines to connect the dots, but in this case, we don't want to actually do that. We're just going to analyze the 4 points that you see here. So there's really one of two ways that you can think about this problem, but really this is an example from the front page in disguise because it's a set of ordered pairs that are just scattered all over the graph. So that means, contrary to popular belief in this case, that we're actually going to go back to those squiggles. If you go back to what we did in the front, we just literally looked at what the x values were, toss those in the domain, what the y values were, and toss those in the range. Since we're on the graph, we could use our index card and scroll across and use that technique since they're plotted out right for us. So I would use this and say the first one's at 1, the next point's at 3, then 4, and then 6. So if that helps you, you can absolutely use that technique to identify what the domain and the range are. So it was 3, 4, and 1, 3, 4, and 6. And then if I don't use the index card, I'm just going to have to kind of scan across. But for the range, it should be -2, 2, and there's 2 points actually at 5. But again, I don't want to write the repeat. And then our last graph example is what we actually would call a parabola. It again gets cut off here at the top, so I'm going to put those arrows on and then grab my index card and scroll. So moving the index card to the left, the first thing that I hit is actually an arrow. So in this case, that means that the domain is heading to the left in this case, because that would be the x direction we're concentrating on. So it's going to be a negative infinity. We know that's a parenthesis. And if I move the index card across, the last thing I hit is that mirrored arrow, so positive infinity with parentheses. Now for our range, coming up from the bottom, the first thing that it hits is the very bottom of the parabola, which is at 0 at our x-axis. And if I move it to the highest point, I'm going to hit the arrows. So that means it's going upwards, it's going to positive infinity. So that gets a parenthesis. But the 0 actually, no open dot there, so I will assume that that is a square bracket. And then our last page is just asking you to take a look at what a multiple choice question might look like. So again, I would suggest that you pause the video and then come back and listen to what my explanations would be for each answer for each of these two problems. So for our first example, I definitely want to make sure that I'm adding the arrows to this one because it does get chopped by the edges of the graph. And notice that for each problem here, we're going to be working with domain. So I can guarantee you in a multiple choice question that the range is probably in one of those 4 answer choices. So you can immediately rule that one out. So you do have to remember which one's which. In this case, since we're working with domain, I want to rotate my card so I can scroll left to right. And what I would do in this problem is I would write the domain the way that you're most comfortable with, even if the answer choices don't look that way. So as I scroll across, the first thing I hit is an arrow, and I'll scroll both ways right away and see that the last thing is an arrow. So the way that I would write the domain for this one is negative infinity to positive infinity. Now, that's obviously not one of the answer choices because they're trying to show you the way to write it in words. So what our domain really means is that there's nothing excluded. There's no x or y value that's not going to happen here. So I would actually choose B. Then for our one here at the bottom, probably the easiest way to rule things out is notice that the endpoints are both closed dots. So the only valid answer choice here is going to be letter C.